Hello everyone, welcome to another video on shell coding on ARM Assembly Linux 32-bit course presented on YouTube. So in this one we are going to talk about the load register instructions and the store register instructions in ARM Assembly. Till now we are just familiar with the move instructions. What does the move instruction do? It do just moving of data from one register to another, or we can say moving of immediate value to a register. What move instruction cannot do is it cannot place around with the memory addresses in our program layout. What I mean to say is we cannot move data from a memory address to a register. For that purposes, for memory operation purposes, we have the load register and the store register instruction in our instruction set architecture. So before explaining about the load register and the store register instruction, I want you to clarify one thing, that we cannot directly access the memory addresses in our ARM assembly program. What I mean to say is we cannot use any kind of instruction like load register instruction or the store register instruction to directly store or load the value from a memory address. What we want to do is we have to just load a register with a memory address, and that register will be used for any further memory operations. So let me just clarify this thing too by explaining the load register instruction. So load register instructions have a destination register and an operand. An operand can be a label and registers. So what does load register instruction do? It loads data from the operand memory address into the destination register. So as we know, we cannot directly access the memory address in our ARM program. So what I have done here is loaded the R0 with the memory address of some label in our program, in our text section or data section. So what does R0 will store after the execution of this instruction is R0 will store the memory address of this label. So then R0 will be used by any other memory operation in our program to operate at this memory address. So after this instruction, what is going to happen is we are loading R1 or 4 bytes from the memory address stored at R0. So what ultimately will happen is we are loading R1 with this memory address. By the fact we know that we cannot directly access the memory, so we are storing the memory address into R0, then performing some memory operations with the memory address stored in R0. It might seem pretty confusing to you, but when we will just create a program and debug it, the queries will be resolved. Your all questions will be just cleared. So wait for that. Talking about the next memory instruction is the store register instruction. What it does is it just do the converse of the load register instruction. LDR just loads the data from memory address, and STR do store to a memory address, and it has a destination register and an operand. An operand can be a register specified in the square braces. So what we are again doing here is we are loading an address into R0 of any label, because we know we cannot just directly access the memory, so we have to do this to operate some to do some memory operations on a label in our data section or text section itself. So what we are doing next is moving some data into R1. So at this stage, R1 will store this data and R0 is storing the memory address. After this instruction, what we are doing is storing data of R1 to the memory address stored at R0. So R1 will be stored at the memory address of this label ultimately. This might seems pretty confusing because we are just doing multiple steps to just perform a single operation, but according to the ARM specifications we have to do this. I think this is for some security purposes where program can mistakenly access the memory directly. So to prevent these kind of situations, we have to do some just messy stuffs. First load a memory address to register, then play with the memory address using that register. So it is pretty confusing. In the first glance you might not understand what is actually happening, but with the time you will gain knowledge, you will gain experience. There is another operand we can use with the load register and the store register instruction is the operand 2, or operand 2 is known as accumulate. So what does accumulate do? It It just adds up with the memory address of the operand 1 register, and that updated memory address will be used to load data from or store data to. What I meant to say is I can say that this accumulate is just like a number which adds up to the memory address in the operand 1, and that updated value will be used to operate on the memory. So what does this accumulate can be? It can be an immediate value register or a scaled register. So a scaled register is nothing but a logically shifted left bits of the register operand. So if you are not familiar what I have just said about the accumulate, don't worry. We will create a program later in this video, and the queries will be resolved. So what we are going to do is to create a program where we will just use all the load register and store register instruction with the accumulate 1 2, and we are going to debug that. So let's move on to our computer screen. So what I have done is simply created a file named arm32 load store instructions.s, which you will get in the description for download purposes. What I have done in this piece of code is declared two sections: data sections for defining some variables which you will use in the program, and a text section where we have used all the instructions we have discussed in the slide, like the load register, byte. It is something different, but you can think of loading a byte into a register from that memory address. It's just that simple. The B indicates load a byte, and the accumulation stuffs which we have discussed in the slide. And a special thing in the program which you can see in the end of the text segment is the address pool. So what does address pool do? It stores some memory address of a variable declared in another section. So this variable 1 is declared in another section other than the current section. The current section is text, and the variable is stored in data section. So we can just simply refer to that variable by the equal to technique, but we can do something professional, or you can say some programming ease to the programming, by which we can use the address pool, which is used to declare some variables, and these variables store memory address of this variable. So let's debug our program. For debugging purposes, we are using the GDB multi-arch, which you have seen from the previous videos, and you are familiar how to just set up your GDB multi-arch, and using the QEMU ARM setup, QEMU ARM utility to create a debugger server or the ARM binary onto the another terminal. After pressing enter, we have created the debugger server on port 1234, and we are accessing using the target remote localhost 1234. After pressing enter, we have got the debugger session remotely of the another terminal process. What you can see here is something different. Load register R0 with something addressing technique we have just seen in the slides. So what we have declared actually in the program, it is the memory address of the variable, or we can say we are loading a register R0 from the memory address of the variable 2. But in the debugger we can see something strange. There are no variable names. So debugger cannot understand variable names. It has to be unique. It has to be processor specific, so that processor can understand. Variable 2 cannot be understood by the processor, but PC, program counter register plus or minus 88, is understood by the processor. So R0 will load the memory address at the PC plus or minus 88, which is actually, let me show you what is the memory address of the variable 2. It is 100C0. So what this piece of expression is actually referring to is this memory address in the program layout. After pressing SI or step instruction ahead, the R0 will store the exact memory address 100C0. So let's check out. It is the exact memory address in the program layout, which is of the variable memory address. This memory address locate to the variable 2 memory address. So what we are going to do next in the program is to load the register R0 or load 4 bytes into R0 from this memory address. And what does the variable 2 stores is a word storing 1 2 3 4 5 6 7 8 in the hexadecimal format. So what does R0 will store? You are familiar with that. It will load 1 2 3 4 5 6 7 8 into the R0 register. If I just showcase you the register value, exactly the same, 1 2 3 4 5 6 7 8. So this way we can easily say that we are loading memory address into the R0 register, and we are using that exact register to load data from, which is specified by the ARM specifications. As we know, we cannot directly access the memory, directly operate on the memory in our ARM programs. So we are loading a memory address in this and operating on this memory address with any kind of memory instruction like the load register or store register instruction. What we are doing next is loading the register R1 with variable 1. So at the debugger level, it is decoded as PC plus or minus 84, which is actually pointing to the memory address of variable 1 in the program layout. If we show you the variable 1 memory address, it is 100BC. After stepping one instruction ahead, the value at the register R1 is exactly the memory address pointed by PC plus 84. Now we are actually doing something strange, loading a register B or byte into the R1 register from the memory address of this register. The R1 register is storing the memory address 100BC or variable 1. And what does variable 1 stores is 4 bytes, byte with 1, 2, 3 and 4. So what we are doing is loading into register R1 with a byte of the memory address specified in the operand 1. After stepping one instruction ahead, the R1 register will store value 1, 0x1. So it is 0x1 because we are instructing the computer, saying the computer, hey, load the register R1 with a byte from this memory address. So it will store variable 1 byte into the R1 register, which is actually the same which we are seeing in the program. Next we are doing loading register R3 with some variable 1 and we are doing just the same things, loading the R3 with the variable 1 memory address 100BC. And now we are using the another type of memory instruction, store instruction. So let us check the value of R0. It is 1 2 3 4 5 6 7 8, which we have loaded previously in the code. And now what we are saying to the computer, store the register's value R0 onto the memory address stored in R3. R3 is storing 100BC memory address, and we know this is exactly the memory address of variable 1. Let me just showcase you once more. So it is 100BC. So we are instructing the computer, store the value at R0 to this address, to this place. After stepping one instruction ahead, if we just look up the value of or examine the hexadecimal bytes, 4 bytes at the memory address of variable 1, it is the same as we have just discussed, storing a register R0 value to this memory address. Now another thing, we are loading a R3 register with the address of the variable 2, which is exact memory address of the variable 2. Let me check it. So it is the memory address of the variable 2 is 10030, and we are loading R3 with that address. Next what we are doing is loading 4 bytes of zeros into the R0 register. So R0 is storing completely 0, R0 is completely 0. Now we are storing the value of R0 to the memory address of R3, and we know R3 is pointing to variable 2. If we step one instruction ahead, what happened actually here is the memory address variable 2 is completely 0, 4 bytes are 0. Next what we are doing in the program is using the accumulate technique, and we have already discussed how we can use the accumulate by specifying the immediate value, by specifying the register, by specifying the logically shifted register. So what we are doing further in the code is loading R0 with some memory address. And what is this? Let us check. So we are loading memory address of variable 5 into the R0 register. And what does variable 5 store is the long string from A to T in alphabets. And what we are saying, load register R1 from memory address of R0. What we are saying is load register R1 with A, B, C, D in hexadecimal. Let us check. So it is hexadecimal A, hexadecimal B, and C and D. So 4 bytes are loaded from the memory address of the variable 5. Now we are saying store the register value at R1 to the memory address R0 plus 4. So R0 is pointing to variable 5, we know, and we are saying move the pointer to 4 bytes ahead. So first pointer was pointing at this point, but doing a 4 plus, it points to this memory address. So now ABCD will be stored from at this position. Let us step 1 instruction ahead. If I just examine the string at the variable 5, we can see the 4 bytes are stored instead of EXECVE. Variable 5 plus 4. So the next consecutive instructions does actually the same using the store technique, load technique, and then the program gracefully exits by specifying the exit syscall. So that's all for the video. If you have any question related to the video, you can just ask this simply in the comment section. You can download all the slides and codes used in this video for debugging purposes. You can download the slides from there. You can locate on my Twitter and GitHub as well, and you can follow as well. That's all for this video. Meet you in the next one.